Okay, what I would do for this one here is I would probably differentiate first. So I'm going to write that down. And once I find a series for that, I'll go backwards later, all right? But I think I can write down, f prime. And what do you get? You get 1 over 1 minus 9x times minus 9. Wow, that's geometric, isn't it? Let's write this over here. Minus 9, and then you're going to get, I'll write this a little differently. 1 minus 9x. And I could definitely write a series down for that. Let's do that. So f prime is minus 9. And let's write this down now. 1 plus, well, that's going to be 9x to the first power. Let's write this way over here. Plus 9x, the quantity, to the second power, plus yada, yada, yada. And this converges provided the absolute value of 9x is less than 1. And if you look at that, it's really 9 absolute value of x less than 1, absolute value of x less than 1/9. Or you could say x is between 1/9 and minus 1/9. All right? So what I want to do is, I didn't really want that. What I wanted to do was maybe go backwards a little bit. Before I do that, though, someone says, what do you mean you're going backwards? I'm going backwards to the original problem, which is this one over here. I'll get my eraser out. I want to start to erase things. I'm kind of done with them. I don't really look at them anymore. Done with this business. I'll retain this in my mind, by the way. Not between minus 1/9 and 1/9. I'll write that up here. I'm going to go backwards. Like I differentiate, I'm going to integrate now. And what do you get? Well, on this side, you get the natural log, 1 minus 9x, and then I'm going to put a constant down, plus c, minus 9. Let's start our integration now. And minus 9 is a constant multiple of that, so let's write this down. What do you get? You get x plus 9, x squared over 2. I can write this a little bit differently, by the way. And this is going to be, 9x, it would be 9 squared x squared. So 9, the antiderivative of x squared is going to be x cubed. This is squared, sorry, over 3. All right? That's not so bad. That goes on. I see the pattern now. And let's see if we can figure out what a c is. And I'm going to pick a number that's easy for me to handle. And when I say that, easy to handle on this side, that's an infinite sum. And the only number that's really easy to handle there, in my opinion, would be x equals 0. That would, of course, give me 0 on the right side. And on the left side, you get the natural log of 1 plus c. Well, the natural log of 1 is 0, so c must be 0. All right, so I think I got my series now. Let's get eraser. It's over here. I know c is 0 now. So the natural log of 1 minus 9x is equal to minus 9 sum. Let's take a look at this. X equals 1 to infinity. I'm sorry, I made a mistake in that. I had x in my mind. N equals 1. That would give me 1, 2, 3. All right? What do you get on the bottom? Looks like n. That's pretty simple. Again, it's 1, 2, 3. The 9, oh boy, that's going to be a tougher one, isn't it? So it's going to be 9 to the n minus 1. All right? Going to simplify a little tiny bit. I'm still going to say minus, but I can bring the 9 in the inside. And what would you get there? Well, 9 and 9 to the n minus 1 is simply just 9 to the n. X to the n over n. All right? So right now, I'm going to say we got x between, let's just remind you, minus 1/9 and 1/9. Okay, I certainly know at 1/9 this would not be a good number to choose. And someone says, why is that? 1/9, if you plugged it in, would give you 1 minus 1, which would be natural log of 0. So I can't do anything about that. So I couldn't include that. My question is, could I include the minus 1/9? Let's give it a shot, see what happens. So we're going to test this out. I'm going to say, what happens when x is minus 1/9? You're going to get minus the sum, n equals 1 to infinity. You definitely get an n in the bottom. Then you get 9 to the n, and then you get minus 1/9 to the n. And this thing simplifies pretty nicely, by the way. It simplifies to this over here. And what about this? It's convergent. AST on it, alternating series test. So I get to include that. All right. So this thing, we gained an endpoint, by the way, minus 1/9 up to 1/9. Don't touch it. All right. I want to look at the k, and I want to see how we did. Did we get it? And oh boy, it's a lot of work, isn't it? Let's see. Yeah, 9 to the n, x to the n. I'm looking at this, by the way, over n. And we got this. We're good to go to the next question. Thank you.